All right, good evening, Elements of Calc 2 students. So we are doing problem number 3A here, and that's going to be figuring out the fourth degree Taylor polynomial at x equals 0 for this function right here. Okay, so let's go ahead and have a look at that. So we're going to go ahead and write down the problem so we can say, okay, we have f of x equals, I'm going to write this as a calculus problem because I want to do, I believe it's x plus 1 raised to the 1/4 power. X plus 1, 1/4 power. Okay, so in order to figure out some Taylor polynomials, we're going to have to start taking some derivatives. So let's think about that. So the first derivative we have, okay, just take this derivative. It's 1/4, 1 plus x plus 1, raised to the -3/4, right? So we're just taking a derivative. So if this 1/4 comes down, 1/4 minus 1, right? You have a quarter, you lend a dollar, you're now 3/4 in debt, times the chain rule, which in this case is just 1, so it's not a big deal. Okay. The second derivative, okay, that's going to be -3/16, 1 plus x. We're going to go ahead and say that's going to be -7/4, right? We just come down with this and we just add 1 to the exponent, subtract 1 from the exponent. Again, times its chain, which is just 1. The third derivative, we're going to say this is going to be 3/16 negative, because that negative, times 7/4, okay? 1 plus x raised to the -10/4, again, times 1, okay? And then our fourth derivative, finally, okay, we have, let's clean up on this a little bit here before I take a derivative. I'm going to say, hey, this is 21/64, 1 plus x raised to the -10/4. Okay. So taking this derivative, we're going to be -21/64 times 10/4 times a -10/4, 1 plus x. And then what are we going to have here? It's -14/4, again, times the chain, which is just 1. Okay. And that's looking like our fourth degree polynomial. Now, the nice thing about this is we have to set x equal to 0. Okay, so that's going to change a lot of these numbers to just zeros or ones. So if I plug in x equals 0, we get 1 raised to the 1/4 power. That's going to be 1. So let's go ahead and make a little chart over here. So my 0th derivative, so f of x at 0. Okay, so I just should have put f of 0 is just going to be 1. F prime of 0, we'll go ahead and write it that way. Okay, that's going to be 1/4. Okay, the 1 plus a quarter, the 1 plus 0 here raised to the -3/4. This is just 1 raised to the 3/4. It's going to be 1. Then we end up with -3/16. So f double prime was -3/16. All right. The rest of this is going to be 1. F triple prime, so F3 is going to be, it looks like 21/64. Okay, I'm just kind of double checking to make sure we have a sign, to make sure the signs are all correct. I think we are looking for that going, saying good. So we're going to say that's going to be 21/64. So F 1, 2, 3, 21/64. Okay, and then finally we ended up with a 210 divided by 16 times 4, which I believe, actually, I'm not going to believe, I'm going to say, okay, let's check that out. 16 times 4 is going to be 64. So we ended up with f to the f, the fourth derivative is going to be 210. Okay, divided by 64 times 4. I got that as 256. Okay. Importantly, we have to worry about the fact that this is going to be negative times negative, which will give me a positive. Let's double check the third one, which I believe is negative. The first one, f triple prime. Nope, f double prime. Okay, so it looks like we're okay with that. Mm-hmm. I'm going to go ahead and double check this guy right here. This is times a negative 16. So this is going to be a positive number here. So f triple prime is positive, and then I think we're okay with the fourth one. Okay, so this is going to be times x to the 0 over 0 factorial. It's just 1 over 1 times x to the 1 over 1 factorial. Okay, this is x squared over 2 factorial, x cubed over 3 factorial, and x to the 4th over 4 factorial. Okay, so we can go ahead and make our Taylor polynomial, which is going to look like x to the 0 is just 1. So we're just going to have 1 plus 3/4 x, okay, minus this 2 times 16 is going to be 32. So minus 3 over 32 x squared. Okay, we're going to say that this is 64 times 3 times 2 times 1, so times 6. So we have 384 here. So this is going to be, it looks like, what was this? This is 421. It's just 21. Sorry, 21. So we're going to say plus 21 over, and 64 times that 6 there is going to be, it looks like 384. 384 x to the 3rd power. Okay. And then minus, okay, because this was a negative here. And this is going to be 256 times 24, 4 times 3 times 2 times 1. So that's going to be 210 over 6144 x to the 4th power. Okay, and then one thing I can do is clean this up a little bit. 3 over 32 doesn't do anything. How about 21 over 384? And then say that's 7 over 128. So let's go ahead and recast this. 1 plus 3/4 x minus 3/32 x squared plus, this was 7 over 128 x cubed minus, and we're going to say 210 divided by, where's my divides button? There it is, 6144. And let's see if I can't come up with a fraction here rather than this horrible thing. Let's see. There we go. It did not give me a fraction. Shoot. Okay. So we'll go approximate this 0.034 x to the 4th power. Okay, so that's what we're looking at for a 4th degree Taylor polynomial for something like this. Take a bunch of derivatives, set your x equal to 0, and go ahead and express the polynomial for us. Okay, so thank you very much for watching the video, and good luck studying, everybody, and take care.